So this is our Earth and Sun online lesson. Now, all this information about the graphs is just before you get started. I'll refer to them again down below. All right? So each of these graphs will be explained in detail. Questions 1 through 7 are right here. Okay? And then it says in 8 and 9. Okay? So we've been looking at how the Earth moves around the Sun and what that motion causes. Now we're going to talk about annular motion of the Sun. And I have a really cool video that somebody made from their window. All right? And as it says in the directions, you're going to look just 2 seconds in. Okay, we're going to stop it. Whoops. Okay, so it's showing the sun rising right here. Let's use this tree as a landmark. The sun is rising here. You can see that it's winter. I'm going to make this full screen. Okay. So you can see that it's winter. The sun was coming up over here. Now, the sun rises in what direction? It rises in the east. We just think it's due east and due west, sets in due west, but actually only on the equinoxes does that happen. Maybe you've noticed driving to or from work or to and from somewhere. If you take Michigan Avenue or if you take an east-west road like I-94, sometimes the sun is rising to the right, sometimes it's rising to the left. That depends on what season you're in. So this for us through a year, we're looking at the sun and it's rising to the right of this. Now we're facing east, okay? Let's pretend we're facing New York. What is to the right and what is to the left? If you're facing New York, Florida or south is to the right, and Canada is, so this would be north and this would be south. Okay, so watch as the sun moves throughout the year. So the starting at 2 seconds, we're going to go all the way over to 1 minute. Okay, and you can see that this is summertime now. Now he just happens to be going through a year. He wasn't really trying to find the sun or anything. But look, the sun has moved very far to the north. Summertime. This video was done in the northern hemisphere and probably like we live in, probably in the temperate zone, okay, about 42 degrees north or so. Anyways, look at how much farther north the sun is rising. This is still looking toward the east, but now it's north of east, before south of east. Okay. We're going to go to the next one, which is at 2:09, and we're going to see where the sun is there. Back to winter again, look where the sun is rising. It's rising way over to the south. Okay? All right, keep that in mind as we do this lesson. Okay? So, what's really, I've talked about that commute and so on, and now we're going to go to this data here. Okay? So, looking at this data for Detroit, Michigan, February 2020, it's going to give us the sunrise and sunset times. What do you think on the equinox, what do you think would be true about these times? How many hours of daylight does everybody have on the equinox? This is February. In March, it's going to be 12 hours apart. Okay, you can see. Now, what we're looking for is a trend. Is the time of sunrise going up or is it going down? We're looking at the data. So this is going to be your first graph. Your first graph, you're going to use the dates that I told you. And graph using the y-axis. Okay. You know, graph. Here is going to be the days. Okay. Here is going to be time of sunrise. This is going to be your first graph, and I've given you the dates. You use the exact dates that I've given you. Figure out your time of sunrise. It's only a matter of 12 or 13 minutes. What I want you to see is the trend. Okay, I want you to see the trend. So, Now what I want you to do is, instead of just paying attention to just those few dates I gave you, I want you to go through the whole year. Whoops, there's March, okay. Look at the time of sunrise in March, 7. Let's look around the equinox. Look at that, rises at 7:41 a.m., sets at 7:40 p.m., 12 hours again. Okay. Now, let's look at April. It's getting earlier and earlier, but there will come a day when things will change. This is June, okay? So if you're looking at this data, wow, remember when it was rising at 8 in the morning? Now it's rising so early. And on one of these days in June, the summer solstice, what's going to happen to the time of sunrise? You're going to notice what happens with these numbers. Something very special is going to happen. I want you to discover that for yourself. Okay? So graph 2 now, for graph 2, you're going to do a general graph. Graph 1, you did data for the days I gave you. It was just a few days in January and February. Graph 2, you are going to do the March equinox. You're going to do June, the summer solstice. You're going to do the fall equinox. And you're going to do the winter solstice in December. I want you only to worry about the trends. We saw from January and February it was going down. When does it start going up again? I want you to show me that in a graph. When does it start going up again? Okay? So that'll be graph 2. Then it says that you're going to make graph 3. That's going to involve the sun angle. Okay? So we were talking about time of sunrise. So what we're trying to discover is, how does the sun change in the sky? You know, sometimes in winter, the sun is out all day. But the whole day in winter is only like 9 hours. And the sun's only like at a 28-degree sun angle. So even though we have the sun out all day, it's at a very low angle, and it's only out for 9 hours. That's why it's so cold. Even though the sun is bright in the sky, it's a totally blue sky. In June, if that happened, the sun would be 70 degrees up in the sky, nice sun angle, and it would be out for like 15 hours. That's why the same sun, its intensity changes because of that sun angle. Okay? Every day it rises in the east, it sets in the west. But sometimes it's up for 9 hours. Sometimes it's up for 15 hours. Sometimes it's at a low angle, sometimes a high angle. If you're at the equator, the days are the same every day. 12 hours of daylight, 12 hours of darkness. You have about the same sun angle between 70 and 90 degrees all the time. Very, very nice. But in temperate zones, and especially at the poles, it's much different. In fact, if you're at the poles, you actually have 24 hours of daylight for 6 months and 24 hours of darkness for 6 months. That's why nobody can live there. Okay? All right. Now, we're going to look at sun angles. So we're going to go to the next place. Okay? We're going to go to the next place. And this will give us our sun angles. Let's see. Maybe not. Okay. Oh, I've actually given you the data right here. Okay. So these are the sun angles. I want you to graph, look how it, the 8th, 13th, 15th, 26th, 30th, 5th. This is the sun angle. Okay. This is going to be graph number 3. So you're going to graph this, and you will submit this graph. Now, just like we did with the time of sunrise, you're going to now extrapolate or extend the sun angle graph. Okay. You're going to extend that graph through the year. What trends, when would be the highest sun angle? And when would be the lowest sun angle? Okay, you're going to look at that. You're going to make a trend graph. Okay, this is worth 4 or 5 points. The fresh graph for the whole year. Now, you can either make a new graph and put the sunrise data and the sun angle data on it, keeping these four. So the very final graph, you could have something like this, sun angle and sunrise times for the year. By the way, all of your graphs, you need to have those things. You need to have a title. You need to define the axes. This would be sun angle in degrees, time of sunrise in minutes. I'm showing you that the spring, summer, fall, winter, you can do it like this. I'm showing you right now, and I don't have any numbers. You don't have to have numbers. You have to have trends. This day here, the spring equinox, and this day here, the fall equinox, there's a little magic going on, okay? When you do your graph, there's a little magic going on. You can see I gave you some hints. I used color. The orange is for sun angle, the green, time of sunrise. We've got orange and green right there together. So that's your hint, okay? All right. So here's some other things that you can use to help, okay? Now, let's look at the questions. So besides all the graphs you're going to do as a group, and you can just assign everyone in the group a different graph, do it however you want. Now we have some questions, okay? Now, this is looking at sunset. We're looking at sunset. The video we were looking at was sunrise, okay? Now we're facing west. We're facing California. If you're facing California west, is Canada to your right or is Mexico to your right? Canada is to your right. If you are facing, so instead of that north and south going like that, now we have north over here and south over here. Because now we're facing west. We're looking at the sunset. Okay? Now, on the exam, I could have sunset or I could have sunrise. I could have either one. You need to pay attention. Are we looking west or are we looking east? Okay? If it's west, if we're looking at California, then Canada's to the right. North is to the right. If it's east, we're looking at New York, now south is to the right. There's a lot of things you have to spend time trying to understand in this. Now, I have points A, B, C, D, and E. If this is due west, what day did I say the sun rises and sets, or the sun sets due west? It rises due east and it sets due west. You have to think about that. And so you will know what day C represents, okay? It says, which way is north? That's question 1. Well, I've kind of already told you that. Which position shows sunset on May 6th? Okay. Is it A, B, C, D, or E? You have to talk about it with your group. You have to figure that out. Which one shows sunset on June 21st? Okay, this is our hemisphere. This is the most daylight hours, and so that's what you have to think about. Which represents the equinox? I said there's 2 days of the year when the sun actually rises due east and sets due west. That would be the equinoxes. The fall equinox, the spring equinox. Okay. Which position shows the day with the least number of sun hours? All right. Is it A, B, C, D, or E? Your group will have to talk about this. You'll have to figure it out yourselves. Now, I also have some possible paths of the sun. If you look here, nature follows patterns. Nature makes sense. Okay? Scientists' job is to observe and try to figure out what's going on with things. Like in that last lesson, I said you could go and look at Eratosthenes, who was in Egypt. He happened to be in Egypt on a certain day and from that he figured out how big the world was, and he also figured out that we were tilted. Make sure you look at that story. Now, look here, and what do you notice? That each side is equidistant, okay? That is how the sun works, okay? The sides are equidistant. This is asking you which lines are possible paths of the sun. A, B, C, or D, okay? Which two paths are passable paths of the sun? This one is showing you the paths of the sun, okay? Why don't the other two work? You need to answer that. Which path could be for December 21, and which path could be for June 21? So these are your questions that you're going to be doing, 1 through 7. This is why the assignment's worth 41 points. There's a lot of components. 8 says explain what this diagram is showing us. You just need a sentence, okay? And number 9, looking at this, is this diagram showing us sunrise or sunset? How do you know? Okay. Is it showing us sunrise or sunset? And how do you know? Okay. It shows you that this is north. It shows you that this is south. It also shows you that this is west. All right. That is your Earth and Sun lesson.